All right, so let's have a look at heated cages by FullDeck and missing a few cards. Standard Sudoku rules apply. The digits 1 to 9 appear in every row, column, and box. Thermometers, digits on thermos are strictly increasing from bulb to tip, and cages, digits add to the total in the top left corner of the cage. If given, digits cannot repeat in cages. So let's see here. So these are going to be our thermometers. And what the rule is telling us is just that as we move from the bulb, which is the circle, to the tip over here, the numbers must be strictly increasing, but they do not have to be consecutive. And then these are our cages. This cage, for example, must sum to 9. This must sum to 7, and so on. So let's have a look. So are there any cages that we can kind of fill in? I mean, 7 is going to be 4, 3, 5, 2, or 6, 1. But that doesn't really get us very far. 1, 2, 3, 4, 5. So this has to be at least a 5, right? It can't be a 5, so it has to be at least a 6. And this is, oops, let's get rid of that. And this can be at most a 5. So 1, 2, 3, 4, 5. I suppose we can start by filling these in, and maybe this will be helpful. And actually, it can't be a 5 in this case, because that will give us a 9 over here, which then completely, takes up our available units of the cage over there. This is going to be 6, 7, 8, 9. This one can happily be a 5, or no, it can't, because it's in a 10 cage. 6, 7, 8, 9. This will be 6, 7, 8, 9. And that looks pretty good. That's going to be 6, 7, 8, 9. That's 1, 2, 3, 4. And I'm starting to think that I should just have color codes for 1, 2, 3, 4, and 6, 7, 8, 9. Although we do have a couple that go up to 5. So let's just continue doing this for now. Five, six, seven, 5, 6, 7, 8. One, 2, 3, 4. 1, 2, 3, 4. Or sorry, 4, 5, 6, 7, 8. Yeah, not totally sure where we're going with this. Not totally sure where we're going with this. This doesn't seem to be helpful. I suppose 9 from 3 is quite restrictive. 9 from 3, how would you make that? 2, 3, and 4, or 1, 3, and 5. 2, 6, and 1. I suppose there's a few ways to to make that actually. But that's at least a 2. And that's at least a 4. Well, maybe that's where we start. So 2, 3, 4 is definitely possible. If this were a 3, so if we did not start this on 1, but we started on 2, and then we took the next available number, which is 3, this would be 3 and 5, and that would be 1. That's also possible as minimums. That'll be 6, that'll be 4. But this would be 4. 4, 5. Well, that can be, but it doesn't have to be 6. So I suppose that's okay. I think this has to be a 1 or a 2. If it's a 3, yeah, that's not going to work. So it's going to be a 1 or a 2. And then this is going to be a 2 or a 3. 3, 4, 5. 5, 1, 2, 3, 4, 3. And I think those are the only possibilities, because if we have a 1, 2, 3 triple right here. So that's helpful, I suppose. But if this is a 1, 2, 3 triple, then that means that this can't be a 3. And if this can't be a 3, then if I were to have 1, 2, 4, 5, 2, that is going to be a problem, because we'll have to repeat the 2 there to make 9. So I'm going to propose that this has to be a 4, right? And then that must be a 5. 1, 2. So that's going to be 2, 3, and 1. And that is how that is going to resolve. Now this can't be a 6, because then I'll need a 4 here, which is taken. So it will be like that. Oh, this we have, which is a 7. Takes the 7 out from there, which consequently takes a 3 out from there. I suppose we could look at our next most restrictive one, which is the 10. But I want to just keep looking here. 4 and 6 comes out of there as well. 3. That's 89. Does this help to look at this? 1, 4, 5, 6, 7. I mean, you can take out 4 immediately, right? 3, 4, 6, 10. You take out 3 as well. So it looks like this is also going to be 1 or a 2. So this is going to be 8 or a 9. 2, 3, 4, 5, 8. That would be a 2. That doesn't work. 2, 3, 4, 6, 1. That would work. 6, 1, 3, 4. I suppose that works. 10, 1, 2, 3, 7, 8, 9, the 12. But we've actually narrowed this one down. I didn't notice that. That is going to be 1 and 9 based on Sudoku over there. That being a 9, unfortunately, doesn't restrict this at all. The 1 comes up from there, which means the 6 comes out. Yeah, that doesn't help us, that 9. That's not going to do anything for us whatsoever. What remaining digits do we have in column 9? We have 5, 6, and 8. Okay, so those are quite high. So this is at minimum of 5. 5, 6, so that can still be a 5, and that would force that to be the 8. But then this would not, yeah, of course, this can't be the 8, and this can't be the 5. That's impossible, based on the thermometer rule being applied here. Either it's 5, 6, 5, 8, or 6, 8. Okay, so that's at minimum of 6 now, and this is at minimum of 5, which means, sorry, this is at maximum of 6, so this is at minimum a 4. 4, 5, 6, 8. That exceeds our quota over there. So if that were a 4, that would be a problem. That can't be a 4. 3, I can put in a 4 here. 5, and I can put a 6, and then I could put a 3, but that's impossible because I just used a 3, and that's going to be the only way I can make that work. Because otherwise, if I didn't put a 4 here, I would put the 5, and then I would be stuck with 8, and then I'd be exceeding the quota again. So 3 is not going to work either. So 2, I'm positive will I'm quite sure it will work. Let's see, 2, you can put a 3, and then I can put a 6, 9. Then I would need a 4 here, which is fine, and 1 will also work. 8, 5, 4. Okay, so my only, can I sufficiently narrow this down? So basically we're saying it's a 2 or a 3. I mean, it can be a 4 though as well, right? But I just can't have 3 and 4. But I can have 2 and 4, for example. 2, 4, 5, 6, 10, 3. And that is fine. It can never be a 1. And if it's a 2, this could be a 6, giving us 8, needing 5, which won't work because of Sudoku. But it could be a 2 and an 8 and a 3, which is fine. So I think our options for here. Let me just quickly go over them again. 2, 6, 8, 5, 2, 8, 10, 3, 3, 6, 9, 4, 3, 8, 2, 4, 6, 3, 4, 8, 1. 1's impossible, so we can't have the 4, 8 combination. So I suppose that is the possibilities for that cell. Yeah, unfortunately, we didn't actually get anything. We at least narrow this down a little bit to 7 or 8. Yeah, and unfortunately, that kind of petered out a little bit. I thought maybe we would get something out of that. Where's 5 in this box? Well, can go here still. 1 has to go here somewhere. Okay, 5, 6, 8, 6, 8. I thought we were going to get something out of that. I did think we were going to get something. What if we look down here? Can we figure out anything? I mean, 12. It's not as restrictive, but we got somewhere with 13. 5 and 4 off the table for this part. So if I did make it a 3, I suppose that has then issues. So 3 won't work because I would have to skip 4 and 5. My next would be 6, 7, and 8. That's already 12, right? So 3 is actually not going to work. 2, if I do not put a 3, I have the same problem. So I would have to put a 3. And then I would have to put a 6, and then I would put a 7, and I would need a 2. Well, that doesn't work. And is there any other way to make that work? And that doesn't work, by the way, just because we already had a 2 here, right, in that hypothetical scenario. So if I have to put a 3, 4, 5, 6, 8, and 1. No, I can't put a 1. Okay. So we do get a digit there. I kind of didn't expect it to come from box 7. We have a 1 here somewhere, but not there. And we do get the 9. And the 1 comes out, the 9 comes out. So that's either a 2, 8 or a 3, 7. So let's see. So with a 1, again, I need to make this either a 2 or a 3. But I think we just said that in the cases where this is 3, it doesn't work. And so this has to be a 2, right? Because we resolved this to a 1. That's not changing the possibilities for the cases where this is a 3. So we can infer that that must be a 2, therefore. Now, if this were not a 3, it would be a 6. This could be a 7, and that would be a 3, which is impossible. This could be an 8, and that would be a 2, which is impossible. This could be a 9, and that would be a 1, which is impossible. So this is going to have to be a 3. 3 comes out. That's a 10 cage, right? 7 comes out. 3s are here. The 3 comes out of this. And the 2. Okay. Let's backtrack a little bit. Six, 4, 7, 5, 7, 3, 2. Okay, let's backtrack a little bit. I guess my kind of deduction about the possibilities for this cell were incorrect. 6, 7. So let's just go through it again then. We have 2 and 3. If it's not 2 or 3, then it's 6. Then the minimum that this can be is 8, which exceeds our quota. So let's work from 2. If this were 2, this can be 3, or it can be 6. But that can't be 3, is I guess the point. So that's 6. That could be 7. 2, 7, that would require 3 here. Can't do that because of Sudoku. And 8 would be 10 and would require a 2, but we already have a 2 here in this hypothetical scenario, so that doesn't work. And I'm feeling like I'm repeating myself here. If this were a 9, we'd need the 1. Right. So that just doesn't work. So then we're saying this is a 3, but let me just test this again before I commit to it. 3, 4, 5, 6, 7, 10, 2. So I guess that's, yeah. It was the basis on that being a 2 and that being a 2 that I excluded that scenario. But then when I resolved this to a 1, that does indeed change our range of possibilities for that cell. So that will be the solution. This will be a 3. This will be a 6, right? And just for the sake of completeness, if this weren't a 6 and this were a 7, this would be an 8 and would require a 1 here, right? And anything higher than that will exceed our quota. So let's put that in, 6, 7, 2. That resolves from Sudoku. We need one more digit here, which is going to be the 7. 6 and 7. This is either 8 or 9. Which makes this either 1 or 2. We have a 1, 2 pair, and we have an 8, 9 pair. That's great. We have a 1, 2 pair. So what that just means is that if this were a 1, then this can't be a 2. The next would be a 3. So the minimum that this could be is 3, 4, 5 is 8, which would require a 2 over here, which is impossible based on Sudoku. Okay. I'm not sure what conclusion I was supposed to draw from that. I feel like there was something and it just flew over my head. If this is a 2, we can put a 3, 4, 5. That's 8, requires a 2. We can put 4, 5, 6 exceeds our quota. 3, 4, 6 takes the 1, which is acceptable. So we do have 3, 4 and 5, and 6 and 1 is one possibility, and anything higher than that won't work. If this is a 1, we said 2, 3, 4 as the minimum requires a 4, which also works. Yeah, and I think we're about to start making a mess of this. Wait a second. I can't put a 2 there. So if it was a 1, then I would end up with the same, which is the 3, 6, 1, right? Because I'd have to skip the 2 anyway. 4, 5, 6 exceeds our quota. 3, 4, 5, or 6. This can be 3, 5, 8 requires 2, doesn't work. 3, 6 requires 1. Okay, so that is the only possibility. But the rest we don't know about. But we know this is a 4, 5 pair. 6 comes out, so 3 comes out. 5 is definitely out. So that's 7 or 8 was 1, 2, which does give us a pair. 1, 2, 7, 8, 4, 5. So I suppose that's either 4, 5, or 6, just based on Sudoku. But 6 we have taken. So that is the 5. Slow down. I'm forgetting about 9. I'm forgetting about 9. Let's put that in. That's the 9. 5. That doesn't actually change anything for us over there. That doesn't actually change much for us there. 7, 8, 1 or 2. I mean, we're definitely making We're definitely making good progress. But I feel like I was supposed to get another digit here, and I'm just just missing it. 1, 2, 3, 4, 1, 2, 3, 4, 6, 7, or 8, 1 or 2. 1, 2, and 3. Well, 2's not there, so either 2's here or it's here. 1 and 3 we've placed. 6 and 7, 6s, 9s. We can place our 9 here from Sudoku. One of these will be the 9. So 9's out from there. We can place another 9. 9's here. 9 is here, but it's not there, because that would of course be an impossible thermometer. 9 is here. That's a very good spot for a 9 on the tip of a thermometer. Takes the 9 out there, which makes that the 2, which makes that the 1, which makes that the 9, and I missed the resolution of our 4-5 pair. So that's good. Did we get a 9 in this box? No, but we know it's in one of these two positions. That comes out. And 9s are looking good. One of these thermometer bulb ends is going to be a 9. 1, 2. Where do we go next? We have a 3. We have a 3 there. Yeah, I don't know when I put that 4 in, but I did not track it properly. So that's a 2 or 4. So what is available? What is available to us now? 3, 8, and 2. Well, 3, 6, and 4, I suppose, is still both possible. So I'm not actually sure that we can resolve that at this point in time. 5, 6, or 8, 2, or 4. That looks good. All right, then let's look elsewhere. Did we knock anything out of this? Well, it looks like we've knocked out 1, 6 pair. We've knocked 2 out from there, which means that the 5 must come out from there. So I suppose we're looking at either a 3, 4, or a 5 and 2. And if that's a 2, then that can't be a 2, so that would become a 1. And that would be the 2, and that would be the 7, and that would be the 8. And all would be fine. So should we start thinking about these dominoes, these thermometers? I'm not sure if we know that much about them, though. I just don't think we know that much about them. I mean, if this is a 9, okay. This can't be an 8, it can be a 7. This can be 1, 2, 3, 4, or 5, or not 5, it could be 1, 2, 3, 4, or 6. There's a lot of possibilities for that. Maybe we should just play some more Sudoku. Let's play a bit of Sudoku. So that's out, 2's here. 2 is there. I mean, it's really not what I would consider useful information. 3's, yeah. I'm not sure that I want to pencil mark anything in at this point in time. What are our possibilities for these two cells? That's going to be 6 and 7. Okay. Good. This is going to be 7 and 8 and 5, where 5 is definitely there. which puts 5 in one of those 3 cells. Looking at 4s, again, I'm not sure that I feel the urge to pencil mark in anything. 6 and 7 is unfortunately already filled in box 7. And what we are missing is 8 and 5 and 4. And we have no further information about those positions of those digits. So we will leave it at that. We can place a 5. Okay. That's nice. I don't see anywhere else to put it. I don't see anywhere else. That fizzled out pretty fast. 6, 7. So 8 is in one of those positions. It's in one of those positions. 9s we already looked at. If this is the 8, what does it mean? It means that's the 2, which means that's the 1. If this is the 8. If this is the 8, that has to be the 8. So does that work? This is the 8. That's 8 and 1. That's a 2. So that's the 8. That is a 2. Which means that this is a 4, which means that that is a 6, which is pretty good. We've hit a bit of a sticking point. Let me look at these thermometers a bit more. Can be 2. If it's not 2, next is 4. Can't be 1, can't be 2. 3, 4, 5. Can't be 3. Okay, it's only 3 digits. 6. Can't be 6. Because we would run out of space because we can't use 7 and 9. So the only digit higher than 6 is 8, but we need two digits. So 5 will presumably work then. 5, 6, and 8. Okay, I mean, I'll pencil it in. 4, 5, 6. So I guess what we are saying is nothing. I was going to say we're saying there's a 5 here, but that's actually not true because we can have 4, 6, and 8. Right, yeah. We're going to need that 5. Okay, so we can't even make a claim about... this cannot be a 6. I just noticed because of Sudoku we have a 6, 7 pair. Okay. 5 comes out, 5 goes in. Getting some 5s. 5's out from there. 5's in one of these 2 positions. That becomes our 4. Maybe we can resolve that one after this. let's just look if 5, 5, 5. 5 is in one of these positions. Okay, to match up with that, presumably we already have a 5 there. Yes, that is correct. Okay, 4, 5, so this is either a 6, a 5 and a 2 is fine, I suppose. Either a 6 or an 8. So let's have a look at this thermometer then. This could be 2. And if it's not 2, the next that it can be is 6. And if that were 6, then we would be in trouble because, again, we would only have, well, we have no digits in place, actually, because we can't place the 8, because that will be an 8. So we can't place 7, 8, or 9. So that's a 2. And that's a 1. And that's a 4. And that's a 6. And that's a 2. And that's a 7. And that's an 8. And that's a 7. That's not a 2, which means that's not a 5, which means that's the 5. That's a 3, 4 pair. Let's make sure we're not missing anything. I have a pencil mark for an 8. Yes, that's correct. Sometimes you get a little bit suspicious when that pops out. 4 and 8. We're just playing Sudoku. So this pair still holds. Okay, and what is this? 1 did come out based on Sudoku from this cell. So this is a 7, which gives us those 2. This is going to be a 3 or a 4 to complete the pair, which means this cannot be higher than a 3. But this can't be a 3, because for this to be a 3, this would have to be a 4 for the thermometer to work. But if that's a 4, then that's a 3. No, that does work. I thought we were going to hit a conflict with the cage. But that's fine. 5 comes out from there. That's, whoops, did not mean to do that. That's our 5. Do we place all our 5s now? 1, 2, 3, 1, 2, 3. Yep, looks like it. All right. Well, let's kind of wrap this up, I suppose. I'm guessing this will have to be a 4, because if it's not a 4, yes, this is a 4. Oops. I mean a 3 is what I meant. 4, 5, 6. Or 8, but it can't be an 8 because of Sudoku from here. So 6 and 8, last digit is a 1. And that's quite nice. So our 1 is in the middle of all of our thermometers, at the intersection, almost. I like that. So that's not a 1. So I suppose that this can be a I'm very tempted to play some Sudoku, but let's think about the thermometer first, I guess. But I'm not sure how far we're going to get with this thermometer. 7, 8, 9. 7 is the highest just based on restrictions from thermometer rules, but actually 7 doesn't work because we can't put an 8 here from Sudoku. Would we be able to put a 6? No, because we cannot place a 7 or an 8 or a 9 actually in that cell. So I suppose we can't put a 5 from Sudoku. So I suppose that's going to be 2, 3, and 4, which actually completes a 2, 3, 4 triple. completes a 2, 3, 4 triple, so then that has to be a 6. And this could be 7 or 9. We just don't know. But this is going to have to be the 9, because it can't be a 6, a 7, or an 8, or a 5. So that's going to be our 9. That's going to be the 7. Okay, so I guess we did get somewhere with that. All right, and now, that's not even a 2. Okay. All right, there we go. So now we can play a bit of Sudoku to wrap the game up. What are we at? 40 minutes. Okay, let's see. Twos is going to be there. Threes. Looks like that'll be a 3, so that fills in our 2s as well. We need one more 3. We need a 4 over here. We need a 4 over there. That's going to be our 4s. Our 5s, I think we already looked at, and those are complete. We're going to have a 6 right there. And unfortunately, wait. Yes, a 6 there, 6 there, 6 there. 7s, well, this is just missing an 8, so I can just fill that in. This is missing the 7, and this is missing the 8 as well. Great, done.